Let's do A. 7 years ago, so so there'll be only one, I promise, one word problem kind of thing on the test. 7 years ago, my son was 1/3 my age at that time. 7 years from now, he will be 1/2 my age at that time. How old is my son now? Well, isn't this like problem of the week number 9? Number 9. This is just like it, right? Different kind of thing like number 9. So what I decided is I'm going to put one problem of the weeky kind of question on each exam. Each question's worth 4 points. So I mean, you could miss 2.5 questions, and that's a grade. So you have a little wiggle room. Anyway, how should we solve that? I know for a lot of people that just seems like crazy. It's kind of weird, huh? It's kind of weird to solve. There's a lot of good ways. In the interest of time, let me just suggest for both. In fact, I gave a hint there, and I'll give you that on the test as well. Making a guess and test table will probably be easiest. So let's do that. Let me show you what I mean by that. I did that before. I gave you a hint on number 9, right? Let's do that again, though. I think it's really good, and I'll have it recorded here. So when they say 7 years ago, my son was 1/3 my age at that time. So I'm just going to go, okay, 7 years ago. And me and my son. I'll just start with what they're saying. 7 years ago, my son was 1/3 my age at that time. I have no idea. Where do you guys want to go? Let's just guess. Purely guess. Excuse me. So anybody's have it does you're not trying to get it right or anything. Just take a random guess. So I just need two numbers where one of them is 3 times as big, huh? How about 30 and 10? I just start with something nice and easy. 30 and 10, right? My son was 1/3 my age. Just guessing, right? Just start guessing. Okay. 7 years from now. Now that's kind of a hard jump. Let me just do. How about let me do now, and then I'll do over here. 7 years from now. Well, I do that. And again, we're going to have, me and my son. So, okay. If 7 years ago, I was 30, how old am I now? If 7 years ago I was 30,
37.
Now I'm 37. Huh. So this is just add 7, huh? And the son's 17, huh? We good? That's just add 7. If 7 years ago he was 10, now he's 17, right? And then for the 7 years from now, again we're going to have me and my son. And again we're just going to add 7 again, huh? Right? If now I'm 37, in 7 years I'll be, add 7, what's that, 44, right? 44. And add 7 to the son? 24. Yeah, 24. Okay. So is that right? I don't know. What other facts are there? Right?
Half my age.
Yeah. 7 years from now, so in this blue section over here, he will be 1/2 my age. He's supposed to be half. Is he?
No.
Not quite. Not far off though, huh? 24 is supposed to be half. It's not? So what do you do about that? Well, why don't we do that? There's various ways you could do that. You could say half should be 22, right? Half of 44, I mean. Or you could grab the 24 and say, well, then this person should be 48. Yeah, right. Either way you want to say it, it doesn't matter. One way or the other, make some kind of note for yourself that it's not the right answer and it's off a certain way, because then on your next guess, you want to know if you're getting warmer or colder. You don't want to know which good way to go. Right now, I have no idea at all. So I'm just going to totally make a row here and take another guess. The first guess just kind of gets you warmed up, gets you going. So I need to guess at another A. You're going to start over again, since this one wasn't quite right, although it was close. I'm not far off. So would it make sense to do something like 31?
No.
Why would that not be a good guess? Yeah, you can't divide it by 3 easy, right? So just pick something that's pretty easily, like 33, or 36, or 39, or 27. You know what I mean? Just guess at something that's easily divisible by 3. Divide by 3, the son would be 11, huh? Is that good? And then we do the add 7. So it says 40, add 7, 18. Right? That's not what I did. I added 7 to both those, right? just add 7, add 7. And then do it again. Add 7, add 7. So add 7. So that 47 and add 7. What's that? 25, right? Yeah. So is 25 half of 47? No. So it's still not the right answer. Now, are we getting closer or are we getting further away? Does it look like we're getting closer? Remember, because that's what they said. It's 7 years from now, it's supposed to be half. So we had 2444 before. Right? Let me circle that. How close was that to being half? Pretty close, huh? So now, 4725, is that closer to half or further away? That's further away. I must be going the wrong direction. Does everybody see that? So however you notate that, notice we're getting colder. If we're playing warmer, colder here. We're going in the wrong direction. So that means back here when I guessed higher, I should have actually guessed lower. So I'm going to go back and do something like 27 or 24. Does that make sense? Everybody see that? See how these numbers are closer to half, aren't they? You double 24, 48, that's only 4 away. You double 25, that's 50. Oh, wait a minute, that's 3. No, maybe that's closer. I'm actually changing my mind now. That's only 3 away from double, right? Maybe that is closer. Yeah, you can tell. I don't have this down as a rocket science. One more guess will help. Yeah, I think we might actually be going the right direction. So you see how I just changed my opinion, right? So how am I doing this again? So double. How about we just double? Double this number, that'd be 48. How far away is that? It's off by 4. Double this number, it'd be 50. How's that compared to 47? It's off by 3. So it seems like my gap is shrinking a little bit, doesn't it? Does everybody see that? So let's try another one. So I was actually thinking wrong. And it's okay. If you start going the wrong direction for a couple guesses, you'll realize it and you go, oh, no, I got to go the other way. Then you just go back, like playing warmer, colder. So I'll do like, how about I do like 39? How about I go up a couple jumps? That's a couple jumps of 3, right? Divide by, am I losing you? Is this making sense? I want a number divisible by 3. Divide by 3. That'd be 13. Add 7. 46. Add 7. 20. Add 7 again. 53. Add 7. 27. How close are those to half? If you doubled the 27, take your calculator, you'd get 54. How close is that to 53? It's only off by 1. I'm super close to the real answer. Do you see that? Am I going too fast? Is this making sense? So I just keep guessing at a number, divided by 3, because the sun is 1/3. And that's the 7 years ago information. And then I add 7 to both those, because we're going to the now. These are my age and my son's age 7 years ago. Add 7 to both. We get our ages now. Add 7 to both again. You get our ages 7 years from now. Now that we see this, by the way, we could actually cut out this middle, couldn't we? And we could just take these numbers and add 14. That'd be quicker. You could do that.
So you're doing the divisible by 3 because of 1/3?
Yeah, because of 1/3. Exactly, yeah.
So
right.
it'd be like 1/4 would be divisible by 4.
Exactly. Yeah, because they said his age is 1/3, it's got to be divisible by 3 or 4 or whatever they say. Right, exactly right. And then I just compare at the end how close these are to being half. And how do I do it? I just double the little one and then compare that. I said, oh, that's only 1 off from being half. So I probably only need to go up by 1 more jump. Next jump, what's the next one?
42.
42, I just added 3 there. And then 1/3 of that is 14. Then add 7, 49, add 7, 21, add 7 again. And you get 56, 28. That's it. That's half. That's exactly half. You can check it on your calculator. So what's the question? How old is my son now? Son now 21. The son's 21 now. Does that make sense how we made a guess and test table there? I mean, you could do it with X's. You don't have to do this way. You can totally do it with X's and working backwards. There's other good ways. I found this is usually easiest for people over the years, but other ways are fine too. And kids can do this because you don't need X's. It's a great thing to teach. All right, shall we try the next one? How are we doing on time? Yeah, I think this is our best place to spend our time. Why don't we go on? If that was too quick, it'll be on YouTube right after class. Let's try B. I'm thinking of 2 numbers. One is 10 less than half the other. Their product is 1518. What are the numbers? List both numbers separated by a comma. I hope this is making sense for you. Let me show you one way. There's not just one. Does anybody want to share their way? Does anybody want to share what their first guess was? How they did it? Anybody? Not all at once. I'm just kidding you. Anybody want to share their guess? So I would just go first number, and I don't know, 10. And then second number, and what does it say? 10 less than half. Oh, so I shouldn't start with 10. That's kind of too low, huh? So how about 50? All right, so how do you do, this number is supposed to be 10 less than half.
Divide it by 2 and subtract 10.
Yeah, so you gotta divide it by 2, take half, and then subtract 10, huh? Is that good? 10 less, 10 subtracted from half. What's that going to be? 40 minus 10, 30? Is that good so far? The second number has to be 10 less than half.
Isn't it 15?
Oh, yeah. I was testing you. Right. Good job. I am a math teacher. I was, all right. Anyway, so 15. Yes, I messed up. So 15. Thank you. Second number. Now, what are we supposed to do? Their product is 1518. So I'm just going to say product or multiplication, whatever you want to. I'll write product, whatever. So that'd be 50 times 15. Was it 750? Okay. What's it supposed to be? It's supposed to be 15. Should be 1518. So it's obviously too low, huh? Way too low. Going to need to go higher. Right? This one's pretty high. So go higher, like maybe 100. I'll just double it. I have no idea. Okay, second number is supposed to be that divided by 2 minus 10, 40, right? 50 minus 10, 40. And then you multiply 100 times 440, and you get 4,000. Oh, wow. Right? Yeah, that got big in a hurry. So that's way too big. Are you tracking with me? This making sense? I started with 50, did the whole thing, got 750, which is too low, but then 100 is like way too big, 4,000. I'm supposed to hit 1518, right? So clearly I need to go lower. So it's somewhere between 50 and 100, isn't it? So I'm narrowing it down, and it's closer to 50 probably than 100, because 100 like was way off, right? So I don't know, like 70, I'm thinking, a little bit closer to 50 than 100. I don't know. And then second number is divided by 2 minus 10. What's that? 35 minus 10, 25. And then 70 times 25. What's 7 quarters? $1.75, and then add a 0. Oh, so we're a little high. We're a little high, so it's a little under 70, isn't it? So I'm tired of playing around. Can somebody tell me the answer? 66, thank you. So I'll do 66. I had a flash insight. Divided by 2, minus 10, 33 minus 10, 23. And then 66 times 23, I assume, is 1518. There it is. Feel like you could do that? That makes sense on the exam? It'll be something like that. Some kind of thing where you set up a guess and test table like that. Questions I can answer on those two? Should we go on to your favorite, the double-digit long division? Yeah. All right. All right, so 26 long divide into 2142 base 7. Remember what you should do to start off to help yourself on these kind. By the way, these are probably the ones you should save for last. I do get the complaint every now and then. Your tests are just too long. Your tests are too hard and too long. I don't know if you. All right, so base 7. So what do we do? Remember on these, you want to go over on the side, and you want to take 26 times 1, 26 times 2. Excuse me. 26 times 3, 26 times 4, 26 times 5. How far do we need to go? Just 6, because remember, base 7, there's not going to be a 7. In base 7, you'll never see a 7. Remember, you need to get those ready for yourself. Whatever number's out here, you need to take onto the side. These are going to be the longest questions on the test for sure. A bunch of them are super quick. These are really long ones. And by the way, it will not be as long as the practice exam. You know, the practice exam, there'll be 25 questions, but they won't be parts A, B. In fact, there's no parts A. Well, there's one question that has A, B, C, but there's just one. All the rest are just one question, one question, one question. Whereas you'll see on the practice exam, I'm giving you A, B, C, D, A, B, C, D, A, B, C, D all the time. So the practice exam is longer than the real exam. I don't want to overly alarm you. Anyway, so how do we get these things? 26 times 1, 2, 3, all that. Well, you just got to do it, huh? Step by step. It's long and it's painful. So I'll do the first one. That's easy, huh? 26. But then times 2, I'm just going to go to a fresh screen and do it. I'm in base 7. You know, again, you know what I think might be easiest is just adding. Is that helpful, or does that make it worse? I think it's easier. Let's see. Let's try. So we have 26, and then if you add 26, the answer is gonna be whatever 26 times 2 is, right? So if you add, here we go. We're in base 7. When you add 6 and 6, you get 12. Now, what do you do with 12? Right? I can't go 1, 2. That's not right. 6 and 6 is 12. Remember all we've learned about bases? 12 is how many 7s? 1 7, and how many left over? 5. 5, good. It's 1, 5, base 7, isn't it? Excuse me. You carry away a 1, bring down 5, because that 1 means 1, 7, and 5 1s. Excuse me. And then we add right here, 2 and 2, and 1. Excuse me. And then I just add another 26, and whatever the answer, that'll be 3 26s, right? That'll be 26 times 3. You tracking with me? So you add again. 6 and 5 is 11. What am I going to do with 11?
Carry away 7.
That's carry away 7, and how much more? 4 more. Base 7, right? Because it's 1 7, 1 7, 4 1s. So let's carry away 1, bring down 4. 11 is 7 and 4 more, huh? And then add these up. 5, 6, 5, 7, 8. 8, but how do I write 8? 1 7, 1 more. So that's times 3. You good? I've added 3 26s at this point, right? So I added 2 26s, got an answer, added another 26, so this is 3 26s. Let's add another 26. So little exciting music for our lecture. Yeah, no problem. And so 6 and 4 is 10. And then 10 is a 7 and 3 more. We good there? All is good. It's making sense. So you just got to keep staying in base 7, right? So anytime you get a total, you just think carry away 7. How much left over, right? Like 6 and 4 is 10. That means carry away 7, 3 left over. Like that, right? Keep going. Add this column. That's 4, and that's 1. So that's times 4 there. That's 4 26s on that one. So then we go again. So let's add another 26. 6 and 3 is 9. Am I going too fast? So how do you do 9? Carry 7 away, bring down 2, huh? And then add right here. What's that? 5, 6, 7. How do you do 7?
0.
Carry away 7, bring down nothing left over. And 1 and 1 is 2. That's times 5. We're almost there. 1 more. And then we'll have it. And then we'll go back and we can do the problem easy. So add another 26. Just keep adding 26s. 6 and 2 is 8. 8 is carry 1 away. Bring down 1. And then 2 and 1 is 3. 2, nice. And that's times 6. So there we go. So I'll carry those back to the other sheet. So 55, 114. What was this one? 143. 202 and 231. So bring that back. I already forgot. 55. So this is 55. 114. 143. 202. 231. Thank you. So we get all those. So that's a lot of. See, that's why this problem is by far the longest on the test, I think. So save this for last. By the way, whenever you take a test where time is an issue, you want to do the easy ones first, right? What you don't want to do is get stuck on something and use up all your time and then not have time on the easy ones, which you could have totally got all the points for. So and I'll remind you on Monday, just go through, do all the easy ones, and then come back to the ones that take longer and are harder, and then you'll feel better too. Okay, so here we go now. 26 doesn't go into 21, obviously. Can it go into 214? How many times? Which number over here on the right is just below 214? That one, huh? So it's 26 times 5. So I put the 5 there, and it's easy once you have these already. 26 times 5, we already know it's 202. And then we just subtract, huh? And 4 minus 2 is 2. 1 minus 0 is 1. Like that? Is that good so far? It's easy once you have these laid out. It's terrible without them, right? And then just bring down that 2. And then 26 into 122. Yeah, what number's just below that? It'd be this one, huh? Yeah, it'd be times 3. So 3 times 26 is 114. Subtract. Now, how do I do that subtraction there? Yeah, put a 2, put a 1, and when you borrow in base 7, you're adding 7 to that, huh? Adding 7 to that. Okay. 7 and 2 is 9, minus 4 is 5. That's your remainder, huh? I was working with my daughter, and she was doing one of those where you have to do mixed numbers, 7.5 minus 3, and this was like 3/4, where this part is bigger than that. And she was like, yeah, Mommy told me you just borrow one from here, and then you just add to this, and then you subtract. And I said, yeah, you're right. You have a good memory. Do you know why that's true? She's like, no. I'm like, would you like me to explain why? Dad, I don't want to spend more time. It's like, no, Dad, I don't want all that stuff. Anyway, so you will run into that same thing. But tell them why. It's important. All right. Anyway, that's the remainder. So the answer then is 53, remainder 5. There it is. Good. So just lay these out ahead of time. And just by adding, right? Just add 26 and just keep adding another 26, another 26. And that one's time consuming now. Okay. So number 12. Classify each of these as true or false, complete parts A through E below. If a number is divisible by 6, then it is divisible by 2 and 3. So we haven't had a good chance to talk about this. What I would suggest on these is just picking a number. It's pretty much how it seems like I do everything. Just grab a number and that fits this. Okay, so what's a number that you know that's divisible by 6, can be divided by 6?
12.
Yeah, 12. That comes to my mind too. I think, okay, how about 12? 12 is divisible by 6, right? 6 goes in there cleanly. Is it also divisible by 2 and 3? Is 12 also divisible by 2 and 3? Yeah, 2 and 3 go into it. Probably the answer is true. Now, why do I say probably? Well, just because you find one case in which an if-then is true doesn't mean it's true in all cases, right? Like if I look out the window and I say, hey, I saw a dog go by, therefore it's a poodle. Because if it's a dog, then it's a poodle. That's not true, huh? Not every dog's a poodle. The statement, if it's a dog, then it's a poodle, is not a true statement. Not every dog's a poodle. But I could say, well, look, I just looked out the window and I saw a dog and it was a poodle. So this is always true. Well, there we go. One case doesn't prove an if-then, does it? But so be careful. So be a little bit careful. Just because you found one number that makes it true doesn't mean all numbers make it true. But probably it's the case. And now, how do you actually know it really is true for all numbers? How do we know? Is that true? Is every number that's divisible by 6 also divisible by 2 and 3? Yeah, why? Yeah, because 2 and 3 are the building blocks. They're in a 6. So if 6 is going in, he's taking 2 and 3 with him. So it's got to be true. So we do know it is always true. It wasn't just a coincidence that 12 worked. But you be a little careful. Now, if you get false, you know it's false. You don't even have to think a second time. Right, let's go on. Let's see one. If a number is divisible by 2 and 3, then it's divisible by 6. So what's a number you know that's divisible by 2 and 3? 18. Good one. Is that divisible by 6 also? Yeah. That's going to be true as well because, again, 6 is made out of 2 and 3. If a number is divisible by 2 and 4, then it's divisible by 8. No? Before, no is correct. Good job. But watch how easy it would be to think it is true. Let me show you. What if I said, well, it looks good to me. What if I go 12? 12 is divisible. Well, no, actually.
16.
Yeah. let me try to do it wrongly. So 16. 16 is divisible by 2 and 4. And it's also divisible by 8. So maybe it's true. Yeah, it's true for 16. But it's not true for all numbers, huh? Not every number, and you guys already know some, right? What are some examples of numbers that it doesn't work for? Yeah, like 12. 12, 2 and 4 go into 12, but 8 doesn't. 20, all kinds of numbers, huh? So there's the poodle case that I was talking about, right? Sure, some numbers that are divisible by 2 and 4 are divisible by 8. But this says if a number is divisible by 2 and 4, then it will always be divisible by 8. And that's not true. That's too strong. That's false. 12 and many other numbers are what we call a counter example, a situation that proves it's not true. Like looking out the window and seeing a German Shepherd. See, there's a dog that's not a poodle. Not every dog's a poodle. That's what we just found. Not every number that's divisible by 2 and 4 is also divisible by 8. 12 proves that, right? That makes sense? So with our last 3 minutes, so the other ones, if a number is divisible by 8, then by 2 and 4, I think that's true. Number divisible by 8, if and only if 2 and 4. No, we already proved that one. If and only if means it goes both ways. Let's go on to the other one. 16. We have it says LCM of A and B, and then it's got the straight bar GCD of A and B. Okay, so what should you do with this? Well, again, I'm going to suggest just put in numbers. So let me just make up a couple numbers. What if and I'll just try to do easy numbers. How about I do like, I don't know, 10 and 2, and the GCD of 10 and 2. So notice that A and B, whatever A is, it must be that in both cases, right? If this is A and this is A, then whatever you choose for A, it's that number in both cases, and same thing for B. Okay. So I just made up some numbers at random. Why 10 and 2? I don't know. They just seem like easy numbers. So let me see if this is true. By the way, this means long divide, doesn't it? Remember, that always means the left number goes into the right. Just turn it into long division if you're a little rusty. Oh, you get a 3x5 card. Have I said that clearly? Write anything you want. Problem, you write out whole problems if you want to, or whatever you want. Both sides of a 3x5 card you can use with you on the exam on Monday. I'm not into you memorizing all this stuff. Just that you know how to do it. Okay, so it's a long dividing is what it means. Is it true? What's the LCM for 10 and 12? Now, it's easy to forget. We've done so much stuff. It'd be like common denominator, like if you're adding a half and a tenth. Remember that? LCM's like LCD. It's exactly the same as LCD, actually. What would be the common denominator for 2 and 10? It's just 10. Yeah, it's the number they both go into. It would just be 10. Right? Remember from algebra, you'd multiply top and bottom by, all that stuff. Anyway, does that go in? Now, what's the GCD of 10 and 2?
2.
Yeah, that's 2. That's the tiny little number that goes into 2 and 10. Like if you were factoring 2x plus 10 or something, what would you take out? So does 10 go into 2? No way. 2 goes into 10, but 10 doesn't go into 2. So this is clearly false, isn't it? Does that make sense how we did that? I just made up numbers. And if you find false, you know it's false. If you find true, it's probably true, but it may be proven later to not be the case. All right.